In this video, I'll discuss secure coding. One of the biggest problems with software is the timelines under which developers are under pressure to deliver a solution. Often, a solution must be put out the door as quickly as possible. And the problem with this is that we can't properly apply security techniques if we're always in a rush. So, the first thing we should consider then are best practices related to secure coding, such as those published by OWASP. OWASP is the Open Web Application Security Project. This is an online resource that has things like secure coding articles, documentation, and free tools available for developers to use. There's also the SANS Institute, which has a number of white papers related to things like secure coding, as well as the Center for Internet Security, again, which has a lot of coding system design recommendations as related to security. But before we can take a look at secure coding best practices, we have to have a clear idea of the security requirements of the solution that is being built. Here on the SANS.org website, if I were to search for SDLC, the System Development Lifecycle, I can see that there is a reading room document here called Software Engineering Security as a Process in the SDLC. So if I were to actually click on that link and begin reading this documentation, then this would be one of the resources I could use to follow secure coding practices. And there are many out there on the internet. So now we can see the software engineering security as a process in the SDLC document loaded here from the SANS Institute. So this is the type of documentation that we should be going into before we start developing from the initial phase of the system development life cycle. Another invaluable part of secure coding is having a peer review. This essentially is having other sets of eyes reviewing code looking for improper secure coding practices or flaws in the logic with the code. So, therefore, security must be a part of each and every SDLC phase. A big part of secure coding involves input validation to make sure that the data being fed into an application is what is expected. We want to make sure that we allocate enough memory to account for valid data being input, and then if we're expecting something like a date of birth, that we make sure that only dates are entered into that field before it's processed. We also want to make sure with input validation that we don't allow executable code to be submitted, for example, on a web form field. So this is all part of our security requirements definition when we build our solution. As an example of a problem with secure coding, consider the Heartbleed bug, which was an SSL TLS bug. This was an open SSL vulnerability specifically that allowed access to data that would normally be secured with SSL and TLS. However, the problem with the way that OpenSSL was coded, and it's since been fixed, is that it lacked checks between client-specified payload value in terms of bytes and what the actual size that was transmitted was. Now, because this wasn't checked properly on the server side, then it resulted in the client being able to read server memory contents beyond what was allocated for the variable containing the client data. So essentially, an attacker could cause the server to read and return the contents of memory beyond the end of the submitted packet data. And that, of course, violates secure coding practices. With secure coding, best practices and recommendations will vary from programming language to programming language. So if we're scripting using a Unix or Linux shell of some type, or using Visual Basic or Microsoft PowerShell, or languages like C, C++, Java, and Python, there will be different best practices and recommendations, although there are some common threads. Consider, for example, the OWASP secure coding cheat sheet on the screen listed now. In the overview or table of contents, we can see the categories related to secure coding. For example, for user authentication, session management, input data validation. Let's go ahead and click on that. Here we can click the link to read about input data validation as it relates to secure coding. Now remember, it's going to vary whether you're using Python or C++ or Java to write your code. But now that we're in the input validation documentation, we can start to go down and read a little bit about the detail related to that. For example, with Java, whether we're using server side or client side code, and so on. As a simple example, consider the code on the screen where an admin privileges variable is being set to a value of true. Then we've got a try catch block, which captures runtime problems or errors. And here we're running a custom function and giving it some arguments, but then there's an if statement testing a condition, and essentially it is setting the admin privileges variable again to being true. Now, the problem with the coding here is that the admin privileges variable outside of the try catch error loop structure is setting the admin privilege to true. So we don't want to give privileges unless certain, very specific, certain conditions are met in a proper fashion. This type of obvious error would be quickly picked up more likely than not with another set of eyes through peer review. In this video, we discussed secure coding.